Okay, so now that we know how CDSs work, we're now going to see how they are priced. We're going to do this in two steps. So first we're going to look at arbitrage arguments that are going to give us a rough guideline on the CDS prices. So we are going to relate the CDS price to spreads on the bond, on the underlying bond, and this will give us an idea of where the price of the CDS should be, but it's a rough approximation. The advantage is that it is a very simple approach that is free from assumptions, so it's a robust first approximation. The second model that we will see later after this one is something that requires more structure, more assumptions, but it will have the advantage of giving us a more precise price for the CDS. Okay, so let's start with the first assumption, which is called triangular arbitrage. So what we are going to do is to build two portfolios. Portfolio 1 has a risk-free bond, okay, with let's call it B, and with coupon RF. By risk-free, in this context, we are talking about default risk-free. So it's a bond, I think, issued by the government that we know it will not default, okay? Portfolio number 2 has two assets. One is a risky defaultable bond issued by a corporation, so let's call that bond C, and let's call the coupon small c, right? At the same time, I also have this asset, this third asset, which is a CDS on this bond, okay? On with some spread as CDS. This is the price we'll try to find, okay? So the idea here is the following. I am building an asset, a second portfolio which has a risky asset, but at the same time I am buying insurance on that risk, okay? So it should be intuitive that portfolio 2 should be equivalent to portfolio 1 because this asset was risky, but I've made it not risky by buying insurance. So this should be equivalent to the risk-free asset, okay? So this is called triangular arbitrage because you have three assets here, and you can imagine like a triangle between these. I mean, if these two assets here were not vertical but one next to the other, you could draw a triangle between the three assets, and hence the name triangular arbitrage. Okay. So more specifically, the relation is the following: if I have portfolio 1, I am long on that risk-free bond B, meaning I receive the coupon RF, and if I have portfolio 2, I am long on corporate bond C, receiving the coupon C, and I am buying protection on the bond. So I am long on the CDS. If I am buying protection on the bond, it means that I am paying the CDS premium, right? So I have a minus here. Okay, I'm paying this premium. So what this is basically saying is that now I can move the spread of the CDS to the left-hand side. The spread of the CDS should be equal to the difference between the coupon on the risky corporate bond and the risk-free rate. All right? With some numbers, so suppose I invest 1 million in a treasury bond offering a risk-free return of 5%. Alternatively, I can invest the same amount of money on a corporate bond offering a coupon of 8%. Then what we are saying here is that to avoid arbitrage, the CDS spread on this corporate bond should be equal to the difference. 8 minus 5, so the spread of the CDS should be equal to 3%. Okay. However, this is not, as I started by saying in the beginning of the video, this is not an exact argument, this is just a rough approximation. And the issue is that this arbitrage relation does not hold exactly. So it will hold exactly if the two portfolios had exactly the same cash flows, but as we'll see, they do not have exactly the same cash flows. So let's go through the details. So this is portfolio 1, the risk-free bond, okay? At the beginning point, the beginning time 0, I assume that everything is priced at par, so I am going to pay 100% for bond B. Then at each period until maturity, I get the coupon rate, RF, and at maturity, I get face value. Okay. Now, portfolio 2. Portfolio 2, I have a corporate bond C. Again, I pay face value in the beginning, I get a coupon every period, and I get face value in the end. CDS, The CDS costs 0 in the beginning, but then I am long in the CDS, so I have to pay a premium every period, so minus the spread, and then there is no face value, so 0 at maturity. Okay. So if I do 1 minus 2, the difference between portfolio 1 and portfolio 2, so I subtract this from this, I get 0 at time 0. Every period I do this one minus this, so that's this expression here, and then at maturity 100 minus 100 at 0. So if there was no default, okay, if we were talking just about risk-free assets, I would look at this portfolio. So this is a portfolio that costs 0 now, costs 0 in the end. To avoid arbitrage, this payment here in the middle would also have to be 0. Okay, but we are in the case where there may be default. So this bond here may default. So let's see what happens if default happens at any point from now until maturity. So if default happens at some tau moment, which can be at any point again from now until the end. Okay. So in that moment, in portfolio 1, I will have a bond, a risk-free bond, which will have some value, which is not affected by the default of this corporation. Recall, this is like a government bond. It has its own price independent of what happens to this firm. Okay. So it's the price at whatever date default happens on this bond. Okay. Portfolio 2, I will have the corporate bond, which is in default, right? So I just get the recovery rate of the bond at that moment. From the CDS, since I was buying protection, I get the corresponding value. So I get the loss given default paid by the CDS. Okay? So in that moment, let's compare portfolio 1 and portfolio 2. If I subtract this from this, what I get is B minus 100. Okay. So now I have to ask, well, what happens here? Are these two things the same? Well, not necessarily, right? Because this bond here has nothing to do with the corporation. This is the government bond, which will have whatever price it turns out to be at that moment, which depends on interest rates, right? However interest rates evolve in the future. So this is not 0, and I don't know how much this will be. Okay, it's random. I don't know this value here. So I cannot say by arbitrage arguments that this has to be 0, because this is not 0 as well. So I can only say that this should be approximately 0. Okay, and that's what we are writing here. So I can only say that the spread on the CDS should be approximately equal to the difference between the coupon on the corporate bond and the risk-free rate. Okay. So this difference here depends on how I measure the risk-free rate. We discussed this when we talked about spreads. So I can use a government bond here, and this would be called the G spread, where I could use swap rates, and this would be called the I spread, right? So depending on which of these rates I use, treasury or swap, I get differences between these numbers and the CDS spreads that are in this range. Okay, as expected, the swap rates are a better approximation for risk-free rates. So using swap rates gives me a better approximation to the CDS spread, right? Okay, so let's try to improve this approximation. So let's try to price the CDS with the asset swap. The asset swap, recall, was that asset we saw in the previous section at the end of the bond pricing chapter, right? So to motivate why we would want to do that, let's assume for now that what I want to do is to price the CDS on a floating rate corporate bond. So not on a fixed rate bond, but on a floating rate corporate bond. Right? So the two portfolios that I will do are the following. The first portfolio is the risk-free portfolio, as before, but the difference now is that this is a floating rate bond, okay? Risk-free floating rate bond, so with coupon equal to LIBOR. Okay, and let's assume that the price is at par. Portfolio 2 is the defaultable part, so it has the risky defaultable corporate bond, but again, this is a floating rate bond, so it will have a coupon that is LIBOR plus something, plus a spread, because this bond has risk in it, so it cannot be just the risk-free rate, it has to be a little bit more. So it will have this spread here, right? And let's assume that the spread is such that the bond trades exactly at par. And then I have a CDS on this floating rate bond, okay? And I want to find what should be this spread here, right? So let's do the same exercise as before, compare the cash flows of the two portfolios. So portfolio 1 is the risk-free portfolio. I pay 100 in the beginning, I get LIBOR in every period, 100 at maturity. Portfolio 2, like before, this is the floater, the corporate floater. So I pay face value here, then I get LIBOR plus the spread every period, face value at maturity. The CDS, exactly like before, I pay the CDS premium every period. So now if I do the difference between the two, I get this expression here, the difference between the CDS and the spread of the corporate bond. Okay. Now what happens in default? Again, default may happen at any moment from now until the maturity, right? So the risk-free bond, again, is living on its own, does not depend on the corporate bond, so default here does not affect here, so it will have some price, okay? But the point now is that this price, since this is a floating rate bond, will be probably very close to 100%, right? If you recall floating rate bonds, the whole point of a floating rate bond is to make the price more stable, right? So this does not need to be exactly 100, but it will be closer to 100 than a fixed rate bond, okay? So we are stressing here that it will be closer to 100. So now when I do the difference here in the case of default, this is not exactly 0 yet because I still have the difference between B and 100, but B is very close to 100, so I can say that this is almost 0, right? So it's still not perfect, but it's better than the previous alternative. So I can say that to avoid arbitrage, this difference here should be very close to 0. And in the sense that it should be more close to 0 than the previous case. So this CDS spread should be very close to the spread on the corporate floater. Okay. All right, the problem is that usually I don't want to price a CDS on a floating rate bond. What I want is a CDS on a fixed rate bond, which is the more common case, right? So that's where asset swaps come in, okay? So let's see how we can use asset swaps. So what we are going to do is we're going to use the asset swap instead of the defaultable floater, all right? So the portfolios now are the following. Portfolio 1 is still the same, the risk-free floating rate bond with coupon equal to LIBOR, okay? Exactly the same as in the previous case. And now portfolio 2, what I do is I buy the asset swap, okay? So recall what is an asset swap. It's a package, okay, where you buy two things. You buy a fixed rate corporate bond, and at the same time you enter into an interest rate swap. And the net result of that is that you get something that is floating. So if you go back to the handouts we had here on asset swaps, okay, here, recall how this works, right? If I am here and I buy the asset swap, I get these two trades at the same time, the fixed rate bond and the interest rate swap. But the net outcome of this C cancels with this, so I'm basically just getting a floating rate component here. I own the bond, but to me it looks like a floating rate bond because I'm getting this amount here that floats, all right? So going back to the pricing here. Okay, so now I have the asset swap package on that bond, and again the net amount is to get the LIBOR plus the spread of the asset swap. And at the same time I have a CDS on that actual fixed rate bond C, okay, with some spread. All right, what are the cash flows? Portfolio 1, exactly the same as before. Portfolio 2, the difference is now that here I see the asset swap. So recall that the asset swap is defined in such a way that in the beginning I pay face value for the package, so that's this 100%. Every period then the net amount I get is LIBOR plus the spread, and at maturity I get the face value of the bond, 100%, right? And then the CDS is exactly as before. The difference between the two things are what you have here. Just the difference is now what you see here is the spread of the asset swap. Okay. What you get here is here it's the same as before. This is a floating rate bond, so it should be very close to 100. What you get in the asset swap now it's a little bit tricky, in the sense that what you get from the two things, from the package, is the recovery rate of the bond. In case of default of the bond, you get just what is left, what is worth, the recovery of the bond. And you still have the interest rate swap, which does not disappear due to default of the bond. So you still have an asset, a derivative, which will have some value, okay? But you can assume that this value is expected to be close to zero, right? And then you have the CDS, which will pay you the usual LGD. So if you add up all these things, you'll get something that is very close to zero, right? So basically, the argument is that this cash flow, to avoid arbitrage, should also be very close to zero. And this is the relation you have here. The spread in the CDS should be very close to the spread of the asset swap. Okay, and this difference is actually called the basis, and it's typically a small value in the order of 10 basis points. Right? If you look at this is a very old screen from Reuters, but the point here is just to look at this this figure here, which they were plotting the CDS spread and the asset swap spread, and you would see that the two lines basically move very close together with each other. So finally, just one more detail, which will actually it will be nice in the sense that it turns out that life is even simpler than what we were just saying. So let's look at the Z spread of the bond. And what we actually find in practice is that the Z spread is even a better approximation to the CDS spread than the asset swap. So instead of using the asset swap, we can just use the Z spread, right? And say that the Z spread is a very quick but reasonably good approximation to what the CDS price should be. Okay. So what's the intuition for that? Where does that come from? It comes from this previous argument about the asset swap that we just saw. So let's go through this example. So recall that the Z spread is computed like this. So this is the example we saw when we talked about the Z spread before. The same numbers here, the same market. So these are already the zero coupon swap rates, 5, 6, 7%. Okay, and if you want to find the Z spread, you basically solve this equation for Z. Okay, and as we did before in that example, the number is 2.13%. Now let's compare this with the asset swap. So with the previous, with what we did in the previous argument. The equation to find the price of the asset swap is this one here. And again, we did this exact same example when we talked about asset swaps for the first time. So if you go back and you saw how we computed the asset swap, we basically solved this equation here. So if you compare these two equations, they look pretty much the same. Right? So you have the price of the bond on the left-hand side, you have the cash flows of the bond, and you are discounting at the same swap rates. Okay? The difference is that in the Z spread, so notice, let me step back. Notice that in both cases we are using risk-free rates to discount cash flows that are risky, right? So we have to use a hammer on somewhere to make the two sides match, right? To make the market price equal to the present value of these cash flows with risk-free rates, right? So the hammer in this Z spread is hitting here in the denominator, right? We are adjusting the denominator. We are increasing the denominator to make the right-hand side equal to the price. In the asset swap, the hammer is hitting in the numerator. So we are adjusting here, we are reducing the numerators to make the right-hand side equal to the market price. So the formulas are very similar. The Z spread and the asset swap formulas are very similar, right? It's just the difference between adjusting the denominator or adjusting the numerator, okay? And so it just turns out that in practice, that the asset swap spread becomes very sensitive to the coupon rate. So it turns out that the Z spread actually provides a better approximation to the Z spread than the asset swap itself. Okay. Okay, so I'll stop here and continue in a subsequent video.